Okay, so this is problem 6.3.35, and they're asking us to find the least common multiple of 14x squared plus 56x, and then also this polynomial right here. Okay, so what we need to do to identify LCM is we first of all need to factor these as much as possible. Okay, so let's start in with this 14x squared plus 56x. And there is a greatest common factor in the problem, so let's go ahead and pull that out. There's a 14 and also an x. And when we pull that out, we're going to be left with x and then plus 4 on the inside. Okay, now the 14 actually isn't in its factored form yet, so we want to write it in its prime factored form. So what we're doing is we're thinking about what numbers multiply to give us 14, or actually let me say that differently. We really can use a tree diagram here in order to be able to, so let me cross that off for a minute. We can use a tree diagram to be able to determine the prime factored form of 14. So with a tree diagram, what we're doing is we're just taking this number and we're breaking it down into any two numbers that you can think of that multiply to give you 14. Okay, so except 1 and 14, but anything else. So 2 and 7. And then we notice that 2 and 7 are actually both prime numbers, so they don't go any further. So the prime factored form for 14 then is 2 times 7. Okay, so this being fully factored looks like this, and when we're trying to identify the LCM, we actually want it to look this way, and you'll see why here in a minute. Okay. All right, so for the next expression, 2x squared plus 14x plus 24 also has a greatest common factor, so let's pull that out. It's a 2, and what we're left with on the inside is x squared plus 7x and then plus 12. Okay. The inside is going to factor further because it's a trinomial, so it's going to factor into x plus 3 and x plus 4. Okay. All right, so now what we're trying to do is we're looking at these two, and we're trying to identify each of the factors. We're going to take a look at how many times the factors occur the most in any one factorization. So that will give us the LCM. And you might want to actually listen to this video again and write those words down because they're very important for identifying LCM. So what you're doing to identify LCM is you're taking a look at each factor and you're identifying how many times it occurs the most in any one factorization. Okay, so we actually have 5 factors in this problem. We've got a 2, we've got a 7, we've got a singular x, then we have an x plus 4, and then we have an x plus 3. Okay, so let's run through each of those. So the 2 occurs once here, and it occurs once there. So the most that it occurs in either of these spots is once. We're not looking to take the total. So we're not trying to take, oh, I've got 1 here, I've got 1 there, so there's 2 of them, so there's going to be 2 here. That's not what we're doing. We're saying how many times does it 2 occur here? It occurs once, and it occurs once because it has an exponent of 1, right? And then it occurs once here. So the most it occurs in either spot is 1 time. That's how many times we need it in the LCM. Okay, 7 occurs once here, no times there. The most it occurs in either spot is once. X occurs once here and no times here, just a singular x. So we're going to need just one x in the LCM. The x plus 4 occurs once here, and it occurs once here, so I need an x plus 4. And then x plus 3 occurs 1 time here, no times there. The most it occurs in either spot is once. So your LCM here ends up being 14x times the x plus 4 and the x plus 3. Okay. And so you don't have to answer, the person that asked this question, just to answer their question directly, this additional 2 is actually contained in the 14. So you're not needing to write it again, basically, and that's because of the process of identifying LCM there. Okay, that's it in this problem.